Hey, working with Chapter 5 homework out of EWA. The first problem I chose for you is problem number 6. It seems as though we have a normal distribution. Did that right here. So I drew you a normal. We have a mean value of 50, standard deviation of 1.2, meaning that we have a 1.2 plus and minus on either side of 50 as our one standard deviation away. That would mean that about 68% of the data lie between 48.8 and 51.2. That's not what they're asking us, but just to get a good feel for the data. What's the probability that the sample mean hardness for a random sample of 10 pins? Now this is going to be a sample. We're doing a mean sample distribution. And we need to know whether it's at least 51. So what I'm going to do is I'm going to get out my trusty TI-84 and I'm going to do a normal CDF. So I'll hit second, distribution. This is what my calculator looks like because he's very sweet to me. If you have an older calculator, you will have to know to put in these numbers but use commas and parentheses as we've been doing before. So there's my lower limit, that's negative infinity. My upper limit is 51. My mean is 50, and since this is for a sample population, I'll take the standard deviation and divide it by the square root of the number in my sample. So let's go on over to our graph, and what we are finding is we are finding from about here, maybe a little further up, on back. So they want to know at least 51. So that would mean anything above 51. Now what I calculated was anything below 51, but I can easily fix that by, and here's my other screenshot of how I calculated this value. I did my normal CDF, and in my calculator, once I hit paste, it pops the numbers in just as you guys would in your older calculators, and I get 0.99. So everything behind the 51 would be 0.9957, blah, 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 blah. And I need to know everything above the 51, so I'll just do 1 minus my previous answer. And if you don't know where your previous answer button, which is on your negative key. For the B part in this question, it's kind of a strange little question. Well, it's not really the question itself, but it's the answer that is actually strange, because the only thing that I would change is that this value right here, instead of a 10, everything is exactly the same except for this 10 is now 44. So I just went ahead and took a screenshot so that you could see the difference. See, the only thing that I'm changing is this 44 here, because that is my random sample number in my random sample. So when I key it in, what I end up with is this number right here, which is a very awkward looking number. What it really is 0.1, 2, 3, 4, 6, 7, 1, 6, 2, 6, 2, 9, 9, blah, blah, blah. So when I round it to that fourth digit, I just have 0. So that's why I said it was a strange answer, but that is what it is. So I wrote it in, and they logged it as correct, so I'm happy with that. Alright, the next problem I chose was number 3, mainly because it's a little different than the others. But once you realize that there are 40 students, it's not that the mean, and I wrote down these numbers because I kind of chopped the problem a little bit, sorry about that, but it was just very long on my paper. So anyway, I wrote down that we have 40 students. The mean time grading one paper is 6 minutes, and the standard deviation of that is 5 minutes. So a big standard deviation for a paper, but that is what it is. And it says that the grading times are independent, and we start grading at 6:50, and we want to be done by 11. If you run the numbers on that, that's a total of 250 minutes. But now my mean is not going to be 6 minutes for this 250. I have to multiply that times my 40 students, so that would be 6 times 40, which would be, and you might have a different number of students, you might have 41, 42, whatever. I'm sure that you do because of the randomization. But your mean would be 240, your standard deviation, and remember this is a sample, so you will be dividing by the square root of 40 when you enter it into your normal distribution on your calculator. The standard deviation is 5 times your number of students, which is 40, and this will be 200. So you're going to, on the first one, run a normal CDF, and your values for this will be your lower limit. We choose it to be negative infinity, or it is negative 1e99. I want to know if I can get this done in 250 minutes. What's the probability that I can get that done? The mean value for this is 240. The standard deviation is your 200 divided by your square root of 40. If you run these numbers, you end up with the 0. And I'm just going to write down everything I got just so that you can see my number, 0.624808. 51183. 51183 is what I get, and then of course it wants to the 4th digit, so I rounded it to that 4th digit. The same thing on the other one, pretty much, but we want to know the probability of getting through in 200, and they added this extra 10 minutes. So I want to know the probability that I would get through in, I think, the 260 minutes because it was added. But this is the probability that it's completed within that time. So for the B question, you'll do 1 minus your normal CDF and negative infinity. And then this would be 260 because they added 10 minutes onto there. Then everything's still the same. This would be my 240. And I believe I still have the same number of papers. So 200 square root 40. And then that answer would be, once you run those numbers, 0.26. 3, 5, 4, 4, 5, blah, 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 but I only care about to here, so I rounded it. The next problem is problem number 7. The A part is pretty straightforward. It's just like the other 2 problems that I just completed. So I wrote down what I entered in my calculator, and then of course you can see the result to the side. You can read through those if you need them. The problem that was different was this B part, where they asked you to calculate sample size. So I went and got the formula for sample size. You'll see that in your notes that I have for Chapter 5. And you'll see a couple of examples also that I did for this. This is your z-score, and how you'll get this, if you'll look on those notes, you'll see a z-score for a one-tailed test, and that's what I'm going to need at the 99% level. So if they wanted the 0.9, if they wanted 0.95 probability, then you get the 95% level. But we wanted the 0.99, so that number is 2.33. If you'll look that up in that table, the standard deviation for this problem is 0.80. They want the error for this one to be the same as problem A, so the error for that would be, let me see, problem A is between 2.61 and 3.0, so whatever that difference is, I'm just working that in my head, I think it's 0.39. Make sure, yeah, it is. And then you'll square that result. I happen to get 22.84, which would then be 23 specimens, because I can't do part of a specimen. So 23 specimens for that problem in Chapter 5. If you need anything else worked, please let me know.